Alright, this is a kinetic energy video, and we just finished talking about work. That's kind of the progress of this video. And I wanted to do a quick intro on kind of what it is by showing you this video. And the general question on page 11 that we're going to answer is, can moving objects do work? Question mark. And here's a little video to demonstrate. Can or can they not do work? If you don't know what work is, you should. But we're going to get there in a second. Let's watch this video. I'll just go ahead and tell you work equals force times distance. Force applied over a given distance on an object. And very poetically demonstrated. We did labs in class on this, but this isn't the lab version. This is the YouTube version, so you get a video. And clearly, I hope the answer is a resounding yes. Moving objects can easily apply a force over distance on a stationary object. All right. So let's move on. Here's what our topics are. We're going to go, one video is going to be on basic and proficient ideas around kinetic energy, and the last one's going to be on advanced. Understand the connection between work and energy. Identify and solve the energy contained in moving objects, and apply the kinetic energy formula. Okay, in general, here's your definitions. Page 11. If you're doing this for the first time. Kinetic energy is a measure of energy in a moving object. Measures how much work a moving object can do, because remember, doot, 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 doot. Energy means ability to do work. So how much work can a moving object do? That's kinetic energy. And I don't really need you to sit through my physics lesson for you to know the faster an object's moving, the more work it can do. We already know that right away. It's one of the reasons I like this topic. And our formula looks like this. Our basic formula is kinetic energy equals mass times velocity squared. And I want you to tell me what matters more, changing mass or changing velocity. So write this question down and answer it and explain why. I think changing and then mass or velocity is more important because I want you to be able to answer that. The answer is it's because velocity is squared. Small changes in velocity end up making big changes in kinetic energy. If you double mass, kinetic energy doubles. Alright, a bigger object can do more work than a smaller object moving at the same speed. It's basically an inertia thing. But if we double velocity, then you have to square it. So that equals 2 squared, which equals 4 times the kinetic energy. If we triple velocity, then you have to put a 3 here. That's 3 squared. That equals 9 times the kinetic energy. So incremental changes in velocity make for, say the word exponential. Exponential changes in kinetic energy. Small changes here make for big changes here because of this fun little squared deal. So here's your basic question on the test. Okay. Not it. This is it. Essentially, which is worse? Getting hit by a 1,000-kilogram truck with a velocity of 1 meter per second, or a 1-kilogram truck with a velocity of 1,000 meters per second. You can solve this mathematically using the formula, or you can just describe your knowledge of the kinetic energy formula to describe why. Well, I mean, come on, the truck's worse because velocity is squared, or you can actually solve it and prove to me the difference. like so. Let's practice using the formula and also demonstrating this principle that we just talked about. Velocity is more important. Kinetic energy equals 1,000 times 1 squared over 2 equals 1,000 times 1,000 over 2 equals 500 joules. Okay, so what we did was kinetic energy equals mass times velocity squared over 2, and we just plugged in the numbers for each part. So I would like you to find the kinetic energy of the bullet. Plug in the numbers and solve for KE. Here's the answer. 1 times 1,000 squared, you can already see where this is going, equals 1 times 1,000 squared is 1,000,000 over 2 equals 500,000 joules. And you can see the units of energy is joules. It's the same for work. Boy, oh boy, gigantic difference, which is why a bullet does much more work on your body, and work equals force times distance. So it's just essentially a much larger force when it hits you, and you're in trouble. And this is the basic idea. Answer this question, prove it to me mathematically. So that's a basic. Now let's look at a proficient example. Let's go here. Here's a blank page. Okay. Proficient. Find velocity given KE and mass. Okay, so what do we have? Let's say a 4 kilogram car, a little toy car, has a kinetic energy that's equal to 40. Okay, how fast is it going? First thing we do, write the formula. Next thing we do, plug in the numbers. Mass equals 4. Velocity equals question mark divided by 2 equals, and we know kinetic energy now, so we put a 40 here. And now we need to get V by itself. So first thing I'm going to do is times 2 on both sides. And now we have 4 times V squared equals this stuff, 80. And then we divide by 4. And that is V squared equals 80 over 4 is 20. And the last thing we need to do, we're not done. A lot of people stop here, is square root them both. So now it's just V by itself. I think it's like 4.4 something meters per second. So you follow through these steps. Copy down these steps if you didn't. Remember, you can pause at any time because this is a video. You can't pause me in class, but you can pause me on the internet. So let's have you try one. Here is a 3 kilogram car. 60 joules equals KE. Find the velocity. Pause it and solve it. Here's the answer. 60 equals 3 times V squared over 2 times 2. 120 equals 3 over V squared. Divide by 3. 12 divided by 3, 40. V squared equals 40. And then root 40 is, I don't know, 15 point something. And that's your answer, and that's your basic and proficient question. Solve for velocity. And the other one is explain two things. for me. You need to understand what will result in a bigger change of kinetic energy, doubling mass or doubling velocity, and why. And then you need to be able to solve just a basic example, plugging in the numbers and solving for KE.